Okay, let's look at example 5. This is a real-world application problem. It says that a manufacturer is going to drill a hole through the center of a metal sphere that has a radius of 5 inches, as shown in this figure. The hole has a radius of 3 inches. So what is the volume of the resulting metal ring? So as you can see in the picture, it's almost like a bead. Um, so it's like a little sphere with a hole in it. Now, you've got to have an equation to kind of model um, the main object and whatever is being taken away from it. So that's what you see down in part A, down here, are two equations. Now, if you had a circle of radius 5 is x squared plus y squared equals 25. So in order to manipulate this, in order to make it a function that we can integrate, what we do is we solve for y. You would get y squared equaling 25 minus x squared, and y would be positive and negative square root of 25 minus x squared. Well, because we are rotating this around, we actually don't need both of these graphs. We don't need the top and the bottom. We just need one. So we decide to just pick the positive square root of 25 minus x squared. So we have our graph here. We have the positive 25 minus x squared. But we're cutting it off with a radius of 3 inches, so we're cutting it off right there. So in a sense, we're rotating this little section just right here all the way around this axis. So there would be a cylinder in the middle that's missing from the entire ball. So what we're doing is, in a sense, we're doing the washer method. So we just have to decide what our outer radii and inner radii are going to be. So for this problem, our outer radius is going to be the function that is furthest away from the x-axis, and that is the square root of 25 minus x squared. Our smaller radii is the line y equals 3, so that's just going to be 3. So when we set up our volume equation, our volume is going to equal pi times the integral. So we're integrating from two different bounds. So where do these bounds meet each other? So we need to figure out where those meet. So the square root of 25 minus x squared, when does that equal 3? Well, we're going to square both sides, get 25 minus x squared equaling 9. And you'll see that x squared will be 16, and so x will be positive and negative 4. So these are the two bounds that we're looking for. So we're going to plug these in, 4 and negative 4. Now we plug in the rest. So we've got our outer radii, which is the square root of 25 minus x squared. We have to square that, and then we subtract 3 squared. And we all do this with respect to x. So we're going to go forward and continue to simplify. So our first term here, the square root of 25 minus x squared, that goes away, right? Because we are squaring a square root. And then finally we subtract 9. Now overall we can simplify this to make 16 minus x squared. That's simply just the simplification of this whole top part. Now we can go forward and evaluate. So our volume is going to be pi times 16 becomes 16x. Negative x squared becomes negative 1/3 x cubed. And we do this from 4 to negative 4. So this is going to equal pi times, we plug in 4, we're going to get 16 times 4 is 64, minus 1/3 of 64, or 64 thirds. We then subtract away, plugging in our lower bound. So this becomes negative 64. And then we're also this is going to be a positive 64 thirds. And we want to further simplify, so we're going to get pi times, we've got 64 minus a negative 64, that makes 128. And then we have negative 64 thirds minus a positive 64 thirds, so that makes a negative 128 thirds. Well, and so all in all, you'll end up getting, see, that'd be 256 over 3 pi for our final answer. So you need to have a good idea of our image. We know that we're going to have an outer radii and an inner radii based on us revolving this around our axes. So when we set up our problem, we need to make sure we have our bounds correct. Once we have our bounds correct, then we just go through and evaluate. The evaluation process is exactly the same as it has been in the past. So just making sure you can double check with your graphing calculator to make sure you get the right answer. But it's all about just making sure you get those first two equations right, and you put it into the proper formula that you're going to use.